Hello, everyone, and thank you for having me tonight at the Cincinnati 2030 District's inaugural Member Impact Celebration. My name is Vincent Martinez. I'm the President and Chief Operating Officer for Architecture 2030, and I was interim director of the 2030 Districts Network for a number of years as it started getting going. So I'm really pleased to see the progress that you've made in Cincinnati, and I'm pleased to be able to present to you tonight about the work to decarbonize the built environment. Now, and we are in a climate emergency, as you're aware, and in an emergency, timing is everything. I'm going to start by talking about the latest IPCC report, which stated that in order to keep global temperatures from rising no more than 1.5 degrees, which is what's outlined as the best target in the Paris Agreement, in order to have a high probability of staying at that level, we can only continue to emit about 300 to 400 gigatons of carbon. So I'm going to put that in perspective with our annual output. Each year, globally, we emit about 40 gigatons of carbon from energy-related resources. So a linear phase out from that 40 annually by 2050, which is when you hear most people talk about a phase out, still emits about 600 gigatons of emissions. So well over our 350 to 400 allowance if we're going to have a high probability of staying at 1.5. What we actually would need is somewhere between a 50 and 65% reduction in the next decade and phasing out fossil fuel-based emissions from energy-related resources by 2040. That gives us a high probability it stays within the 340 to 400 range of gigatons emitted. So this is really the timing we have. So we have an immediate peak, a drop, cut in half roughly in the next decade, and then cut up the other half in the following decade. I'm going to tell you about how that's possible. In the building decarbonization, we think about it in three different lenses: new buildings that have their emissions, existing buildings that have their operating emissions, and then embodied carbon of all the materials and construction that goes on in the built environment. Now, we've seen these statistics before from Architecture 2030. These are global statistics derived from the Global Alliance for Building and Construction's Global Status Report from last year. They're going to be releasing their report here in about a week. So we'll see how these numbers have shifted. But building operations are essentially 27% of global emissions. And this is heating, lighting, cooling, water, and plug load, your traditional operating systems. 10% is of the total emissions pie is building construction materials. This is typically structure and substructure of buildings and the materials that go into them in the construction. There's also a new wedge that the Global Alliance has indicated, which is other construction industry. And we think this is roughly the exterior built environment, the roads, the bridges, the infrastructure, as well as other building materials that aren't in the structure and substructure. So this gives you a sense, it's roughly half and half about building operations and the embodied emissions associated with materials and construction. Now, we are slated to continue to build at a rapid clip. Over the next 4 decades, we're expected to double our current existing worldwide building stock, about 2.4 trillion square feet. Most of this expected to take place in urban areas. This building boom over the next decade will predominantly be in the global north. China will continue to build, Europe and North America. And then we see the building boom move to the global south, particularly Southeast Asia, Africa, and Latin America is where we'll see a lot of the building between 2030 and 2060. But in 2040, when we're supposed to have phased out all of our emissions from the built environment, 2/3 of those buildings around in 2040 will be buildings that we have today. So if we don't intervene and improve and reduce the emissions to zero of that existing building stock, we're still going to have those emissions in the future, and they're going to continue to be a problem for us. So looking at revitalizing our existing infrastructure, reducing operating emissions from them is a critical step, and we'll talk a little bit about how that can be done. But first, let's talk about building operations from new buildings as well as existing buildings. First, new buildings. New buildings, we believe the way to zero carbon operations is really a three-pronged strategy. We need to make sure that the buildings are efficient. That's a big part of the work that's happening at the 2030 districts, both for new buildings and existing buildings. We need to make sure that the buildings are using systems that are either all electric and powered by renewable systems, or that they have some form of decarbonized thermal energy for their heating, and then their electricity use is powered by 100% renewable electricity. So let's unpack a little bit about how we're doing. So this is the about how we're doing on energy efficiency. The latest code standards, ASHRAE 90.1 2019, roughly equivalent to the International Energy Conservation Code of 2021, are the bars on the right in terms of energy use per square foot. The bars on the left of each of these areas are the CBEX average, the Commercial Building Energy Consumption Survey that you all use as a baseline for the 2030 districts. And what you can see here is that even just the latest energy codes are significantly improved to the baseline standards. So just adopting the latest code in your jurisdiction can take you, over 50%, 60, 70, 80% way there in terms of just through energy efficiency. And we've squeezed out so much energy following these new codes and standards that really so much of what's left is just the plug load. So the fan loads, the heat, the hot water heating, the space heating are all really, really, really efficient now. So just adopting the latest code gets you really, really far away there in terms of zero carbon emissions. At the same time, we're seeing a proliferation in renewable electricity. You can see this is US solar electricity generation. And you can see that around 2010, the projection from the US Energy Information Administration was that we wouldn't really increase solar production very much over the next decade. But the actual is pretty impressive. We've actually doubled the capacity of solar on the US just in a 4-year period. And we're slated to continue to double at that rapid clip. The projections will continue to go up and up. And I'll talk a little bit about why that is. Wind, very similarly, the projection in 2015 is it would essentially remain stagnant. And what we've seen instead is a doubling since 2015 of what was currently already in the market. So we're seeing tremendous impacts on proliferation of wind and solar. We're seeing the reason for that, and it's happening globally as well, is the price of these technologies are going down and down. You can see in over a 10-year period, the cost of a megawatt hour of electricity from solar went from $359 to now roughly $40. It's the cheapest form of new electricity generation with wind and solar. And we're starting to even see them phase out existing fossil fuel plants for electricity, not just being the majority of new generation capacity. We're also seeing the same trend happening in battery storage, which is really important for seasonality differences of using renewable electricity. And but both of these, the reason we're seeing these price drops is these are technologies that are improving year in and year out, and they're getting cheaper and cheaper to produce. So what that tells us now at Architecture 2030 is that we are ready to actually meet the 2030 challenge today. That we have the technologies on energy efficiency, and we have the renewable energy resources to reach zero carbon operations at this moment. And so we're encouraging all the 2030 districts and all the practitioners to focus for new construction to achieve zero carbon emission operations today. We're actually not alone in that, and we're actually seeing policy examples where jurisdictions are making zero net carbon buildings the norm. In just a few weeks, the City of Boston's planning agency will pass a new zoning ordinance that will require buildings to meet carbon emission performance standards for new construction, and then have on-site renewables and procure the remainder of their energy use from renewable power programs, a variety of methods. So we're seeing that this will be the norm. And Boston's got not only a colder climate, it's got humidity as well, but it also has very complex building typologies like laboratories and hospitals. So if they can do it in Boston, we believe you can be doing it anywhere around the world to reach these goals. Now let's focus on existing buildings now. The same formula applies to existing buildings. We need to improve the efficiency of those buildings. We need to make sure that they're powered by decarbonized systems, either through electric systems or another form of decarbonized thermal energy, and that all of those energy systems are powered by renewable electricity. So when we think about the existing building stock, though, our research has led us to have a two-pronged approach. When we look at all the existing buildings, we see a very small number of buildings in the downtown cores, like 2030 districts. Approximately 5% of the total number of buildings in any city are responsible for about half of the emissions, roughly. Depending on the city size, it's a little bit more, a little bit less. Now, the other 95% of buildings, literally hundreds of thousands of buildings in certain cities, are responsible for the other half of the emissions pie from the built environment. And you can learn more about our research on our Achieving Zero website, which I'll talk about in a moment. But with the big buildings, what's really interesting about big buildings, and you're familiar with this with commercial real estate, is they typically have long-term capital improvement cycles and budgets. Maybe it's 5 years or 10 years, you're going to improve the building, either the systems, or aesthetically, some buildings move into from like a Class A office building in the market and need to move in the Class B category and need to be revitalized in order to be back in the Class A. So there's these improvements cycles that are sort of built into commercial real estate, and leveraging those for decarbonization is a great time to do that, the upgrades. There's also, I mentioned, a small number of buildings that are responsible for most of the emissions here. And so we can get a really large set of impact from a small number of buildings that are working towards these goals. And the 2030 districts are examples of that. We also know that the systems in these buildings are very complex and very significantly from building to building, which leads us to more performance-based targets. So that's where you see that the 2030 challenge goals were performance-based for existing buildings and looking to reduce emissions by 50% by 2030. And those are opportunities for design professionals and real estate professionals to work together to find out what's best for the system. That includes renewable technology and procurement. It includes system swap outs at end of life and improvements for efficiency in the envelope, all together working to achieve these reduction goals. But we've also seen policymakers take an interest in large existing buildings and create policies around building benchmarking disclosure ordinances, as well as building performance standards. And which started as just a handful of cities is now a national coalition of cities and states that are working to develop performance standards for existing buildings. Some of these are energy-based and some of these are emissions-based. Those that are emissions-based, we think, are really driving towards the goals and ratcheting down emissions over time, and allow for a variety of performance-based pathways like renewable energy procurement and generation, like system swap outs for clean electric systems or decarbonized thermal, and then allow for efficiency to play a role as well to reach the targets. Now, the other side, which is really challenging, is the hundreds of thousands of buildings that are smaller buildings, usually under 20,000, under 10,000 square feet. And there's just so many of them, and they're responsible collectively for the rest of the emissions in the built environment. But they don't have a typical planned capital improvement cycle or budgets in the same way that large commercial real estate does. So adequate financing is definitely a critical barrier to getting these energy upgrades in these smaller buildings. And again, we have so many of them that we need to think of phased approaches to reaching them over time, and not on all at once date certain mandates for these large majority of small buildings. And finally, that what is working for us is we recognize that the systems at these levels at buildings are relatively simple and consistent. We know exactly where the carbon emissions are coming from. The large majority is coming from heating, hot water, and space heating. Some from cooking, but mostly that's where we're seeing that. So focusing on those systems, we can be more prescriptive about the approaches we take to the smaller building stock. But we have to leverage what we call building intervention points, which are points in which the building is already going to go through some sort of improvement process, or there's an opportunity for financing or low vacancy or opportunities to go into the building to do the upgrade where we're not disturbing folks. So that can be a capital improvement cycle like we talked about for large commercial buildings. But for smaller buildings, it can also be times of lease or sale when the property is getting ready for sale, or after it's sold, it can be upgraded because there's a financing mechanism there. Either the property owner is getting the building ready to sell it at a higher value and wants to improve its asset value, or the new owner or tenant is coming in and wants to improve the building. There's financing associated with low interest mortgages over long terms, as an example in the residential market. But we can also look for periods when we're renovating other systems that might not be our mechanical systems or our envelope systems that give us an opportunity to build on top of that, or equipment replacements if some of the equipment dies. Like our water heating systems, to replace those systems with more efficient technologies, as well as those powered by decarbonized systems. But there's also opportunities in the movement to improve the life safety and resiliency of real estate in the smaller building stock, as we work for incentive programs or policies on resilience and life safety to do the decarbonization at the same time. And we think that these are really, really critical to get at scale, because they reduce the upgrade cost. If you did it at one of these interventions, you're already doing work in the building, you're not coming in cold, and so the costs are not as high. You're talking about incremental costs instead of complete upfront costs. You also mentioned the financing options for low interest rates over longer terms that are available that could be bundled with the upgrades, and the less disruption, because many times the building might be vacant from tenants or occupiers. But it also ensures that these cycles of renovation will happen over time and consistently, so that we're not, again, not burdening the workforce or the market with throwing technologies and workers at thousands of buildings all in the same year, but that we upgrade them consistently. And it also includes for long-term job creation. More of this can be found on our resources section of the Achieving Zero website at achieving-zero.org if you would like to know more. We are seeing policy examples in this space too, so I wanted to mention that the city of Ithaca is looking at decarbonizing every single building within its jurisdiction, and pretty much all of those buildings would be considered small buildings. So they're building financing mechanisms, workforce training, system education about how we have what we need on the shelf technology-wise, but we need the workforce, we need the understanding about how do you finance this work for smaller buildings, and they're working towards those goals. And we're hopeful that we see more and more jurisdictions approach the small building stock. So how is all this working for us on building operations? Where are we typically coming from, and how much have we improved since we started to focus on this? Well, this shows the change of floor area, operating energy use, and emissions since 1995 to 2005. And you can see that they're tied together. As we increase building floor area by 23%, we also include building energy use by 20% and building sector emissions by 20% roughly over that same period of time. And this has been true since the dawn of the Industrial Revolution. Now, if you look at where we've come in since 2005, since we introduced the 2030 challenge, since we've started to introduce more efficient building codes and standards and policies, you see that floor area has gone up. We've added 53 billion square feet of buildings in the US, about a 20% roughly, just under 20% up increase. But at the same time, we've kept energy use level in the built environment in the US and actually reduced emissions by 30%. This is unprecedented since modern history. This decoupling of economic growth in the building sector, flatlining energy use, and actually reducing emissions. A big part of the reduction of emissions comes from that proliferation of renewable energy. If you were to go back to those slides, you'll see a lot of that started to grow exponentially in around 2005. So that this is despite the recession, we're seeing that this trend is moving forward also globally. So let's unpack that a little bit. I mentioned about the importance of renewable energy. This is looking at emissions and a little bit where the fuels are. And you'll see that, again, energy use remained level, which is what you kind of see that on the bottom graph for on-site gas and oil and other fossil fuel uses on buildings. But the electricity emissions have gone down considerably. And that's what's actually driving a lot of the emission reductions in operations of the built environment over the last 15 years. But projected, that's going to continue to increase. You saw where the trend was for renewables. So we think that we'll actually phase out electricity emissions rapidly. But the question is, how do we get at these on-site fossil fuel uses, and how do they decarbonize over time, and leveraging intervention points and capital improvement cycles to bring them down from the existing building stock? So this is where the plan is, and we're in a good trajectory to reach a zero carbon operations by 2040. And we're also seeing these trends play out at a global scale. So floor area growth, this is energy consumption. You'll see it's starting to flatline a little bit, and then emissions are actually going down again, because we're seeing the same trends we see in the US for the last 15 years now, starting on the global scale. I'm going to spend a little bit of time talking about embodied carbon. I know it's not a set goal of the 2030 districts, but it is an emerging area of interest and really requires all of us to work together towards this issue. Now, I mentioned about the doubling of the building stock and how much of that emissions from that building stock of new construction is embodied carbon with the materials and the construction versus operation. Well, in year one, before you turn off any lights or systems in those buildings, it's all embodied carbon. It's all in the materials. And it actually takes well over 20 years before the operation, or close to 20 years before the operational emissions even get close to covering the amount of upfront emissions. And we actually think that those will decline, again, because of the proliferation of renewable energy. But what is concerning is that the time value of carbon, again, we have to have emissions in the next 10 years, phase them out by 2040. So if we don't get a handle on embodied carbon, those are emissions that go up right away that we then have to sequester over time to pull back out. So it's really important we get a handle on the materials and the construction practices of our new construction. And we think that there's strategies for both reuse, reduce, and sequestration to help us do that. I'm going to go in a little bit of detail about each. On the reuse category, we've often heard the comment that the greenest building development or neighborhood is the one that's already built. And we believe that that's true. repurposing existing urban areas helps reduce on growing infrastructure needs from urban sprawl and the embodied carbon associated with that infrastructure. We also know that existing building reuse and revitalization is really critical to make use of the carbon that we already have in our building stock, and that many of our properties are vacant and need upgrades. And so we not only reduce the operating emissions, but the embodied carbon of building new. But we also have an opportunity to reuse existing building materials through deconstruction rather than demolition. So that's on the reuse side. On the reduce side, we recognize that we don't want to grow too fast, too big on a regional scale because of the infrastructure implications and the embodied carbon there, that we're better off doing infill and densification and make use of that infrastructure that we already have and reduce the need for new ones. But we also have opportunities at the building level to optimize the structure, in many cases use less material or use lower carbon traditional materials that we would see like concrete and steel, which are working really hard to decarbonize their heavy industry emitting sectors. And then we also know the built environment is an opportunity to sequester emissions, not just through more traditional systems like timber, which is getting a lot of interest in sort of mass timber for larger buildings, but also in our other materials like concrete. People are mineralizing CO2, putting it in, creating aggregate. They're injecting CO2 into the concrete mix. We're mixing biomaterials in with traditional materials and scaling those. But there's also opportunities in our landscapes and urban infrastructure to look at sequestration opportunities in vegetation. All of this can help lead and draw down emissions. And we're seeing a number of different disciplines in the design professions taking their own stock of where they are responsible for embodied emissions. You've all heard of the AIA 2030 commitment program, which has a lot of synergies with the 2030 districts targets for design professionals in architecture, but we're also seeing mechanical engineers through MEP 2040 focus on their systems, and the leakage of refrigerants is one example of that in terms of emission source. Structural engineers focusing on optimizing structural design and focusing on procurement of high impact materials. Climate positive design, which is focused on landscape architecture of reducing emissions and their material selection, as well as opportunities for sequestration. And contractors also now have a commitment focusing on how do they help reduce emissions in construction practices through electrical equipment, as an example. So this is all an evolving landscape, and all the different disciplines are taking stock of this and working towards this. But we're also seeing it happen in policy making. I'd like to mention that we're seeing cities around the globe leading on policies to focus on embodied carbon, either at the material level, like low carbon concrete codes, or on a whole building life cycle assessment and targets. And our colleagues at Carbon Neutral Cities Alliance have been leading on that work, as well as C40 Cities. And Carbon Leadership Forum has toolkits for both design professionals and policymakers on embodied carbon policies. Now, just a few more slides to end here is going back to my points about the reuse of existing buildings being both a synergy for operational emission reductions through retrofitting these buildings for energy upgrades, like we mentioned, through intervention points and capital improvement cycles, but also that keeping these existing buildings and revitalizing them instead of building new buildings to meet those needs is also an embodied carbon win. And so the 2030 districts, I think, can play a really interesting role in this intersection. And in order to support that, Architecture 2030 has recently launched something called the Carbon Avoided Retrofit Estimator just this week, which focuses on quantifying the impacts of that, keeping existing buildings for both operational and embodied carbon reductions, and quantifies that over time. And it goes back again to that time value of carbon, about the impacts that we're doing up front in terms of embodied carbon that we can't get back, but we can adjust the operations over time. And finally, I just want to recognize that the building sector is just part of the broader built environment. So buildings, and then there's infrastructure and the in-between spaces of the exterior built environment beyond the building. And we're engaging in new relationships with civil engineers, urban planners, and landscape architects to focus on opportunities for operational emission reductions, embodied carbon reductions, and sequestration in the exterior built environment. And I think 2030 districts are ripe for this area because you have a membership of the buildings, but conceptually we're in a district. And so we can talk about opportunities in between buildings for these nature-based solutions that reduce not just embodied carbon, but also are great opportunities for stormwater infrastructure, for biodiversity, for livability, for lowering urban heat island effect. So there's just so many co-benefits to focusing on infrastructure and planning that we're excited to be involved in this role. So I encourage you to reach out to Architecture 2030 and continue to be involved. We'll continue to be involved in the 2030 districts movement. And congratulations to all of you and your accomplishments tonight.